Hi, my name is Stephanie Vasquez. Today I'm breaking the oral presentation of the paper named Creating a Corpus of Historical Document for Emotion Identification. The authors are Dr. Maria Somo de Villa, Dr. Rosalba Loreto, Dr. Elena Gonzalez, and myself. This is the content of the oral presentation. Each one is a section of the written paper and will be briefly explained in the following slides. Let's start with a little introduction to the subject of research. The importance of historical text lies in the fact that references of authors, titles, and places within manuscripts represent an intellectual portrait of a specific time in history. All this handwritten work is a bibliographic heritage, a valuable testimony of a historical period preserved to this day. The particular case of conventual texts, written mainly by religious women, help us understand several aspects of their daily life, which was embedded with manifestation of the supernatural divine. The handwritten testimonies of women in the cloister show the importance of the role of nuns and pious women in the development of various literary genres. The corpus to be produced will be a compilation of digital files containing historical texts, which will be automatically analyzed for motion identification. The texts were mainly provided by the researcher Dr. Rosalba Loreto Lopez, and the text use as discrimination criteria their length, century of creation, place of creation, as well as their type, like mainly biographies, autobiographies, and personal letters. These texts have already been translated into contemporary Spanish and have been previously reviewed by expert historians and or linguists in order to guarantee their validity as historical texts. Such corpus will be the dataset for an emotion identification model based on machine learning or deep learning techniques. Historical corpus and text collection have been built for various languages like Arabic, Chinese, Dutch, English, in order to allow linguists to examine phenomena and develop linguistic theories. Also to support the development of natural language processing tools through the provision of training and test data. The transcription of historical documents is extremely important for the creation of digital libraries. In this regard, researchers have conducted projects for the transcription of medieval documents like the Percival database, or a similar work was made with the Rodrigo dataset. Regarding the mining of historical texts, we can find work such as the Ryan Report and the work Trading Consequences, part of the Digging into Data project that facilitates the goal of helping historians understand the economic and environmental consequences of the commodity trade during the 19th century using text mining. Within the analysis of historical texts in Spanish, we can find the work Codea, that is a corpus of Spanish documents preceding 1700, the Digging into the Early Colonial Mexico, that is a project that explores computational techniques using a big data approach. And in the area of sentiment analysis for historical texts, there are tools such as Alcide, that's an online platform for the analysis of historical content. There are other lexicon-based works to quantify the emotions in non-contemporary text. This approach has been applied to the German DTA corpus. There are also some works dedicated to mining or to the sentiment analysis only from religious texts. Mainly, these are works that make comparisons between representative texts of different religions, and their objective is to explore similarities and differences between various religious texts. After a review of the listed works, it was noted that there are few works devoted to the analysis of historical texts in the Spanish language. Many European corpus analyses have been done. Furthermore, it should be highlighted that the text in the Spanish language have been automatically analyzed for purposes other than sentiment analysis, such as the transcription of handwritten documents or the obtaining of geographic data. This is why the development of a research project for automatic analysis of historic texts to identify the emotion is an opportunity to contribute to research in the combined fields of computer science and history of feelings. Long texts often have different characteristics like negated expressions, bursts of intensity or degree, intensifiers, etc. that complicate the use of current sentiment classification algorithms on them. We seek to obtain a methodology that improves the automatic classification of extensive text with different applications such as the detection of happiness and well-being, improvement of automatic dialogue system, etc. In this case, extensive text correspond to historical text. For their analysis, we want to develop a methodology based largely on text mining and machine learning or deep learning, capable of analyzing longer historical text in Spanish in the future. In the methodology proposed for identifying emotion, one of the first and most important steps is, therefore, the creation of the corpus of documents written mainly by cluster religious women, since there is currently no public corpus with these characteristics. In order to build a model that identifies emotion in long text, the methodology to be followed can be divided into three main parts. First, obtaining and preprocessing the corpus. The second, the construction of an emotion identification model. And finally, the results analysis. The figure below shows the process implemented for phase one of the methodology, which consists of obtaining the text for the creation of the corpus and their preprocessing. We can see here the manuscripts below, and those manuscripts become part of the corpus. Then after applying the pipeline preprocessing, we obtain the preprocessed text, and then we can obtain also the domain-specific lexicon that is based in an emotion model. And after all this work, we can proceed to the extraction of features. The following table shows a description of the documents contained in the corpus and some of their characteristics. Initially, we had access to some unpublished text written by 7 different women that live in the 17th and 18th centuries in New Spain, 7 autobiographies, 5 spiritual diaries, and adding up to 12 different documents. These texts have been paleographed and translated into contemporary Spanish language by experts. However, these texts were not enough to train a machine learning or deep learning based model for emotion identification. Therefore, it was decided that it was necessary to gather more text with similar characteristics. In the next stage, 4 other collections of documents were obtained and added to the corpus. Are Práctica de la Teología Mística, Diálogos Espirituales, Monjas y Beatas, as well as some works from Sister Marcela de San Felix, all of them previously published documents. We can see here in the table several of the characteristics of these documents, like the number of documents in each one, the number of authors, the years of creation, place of creation, and some data about tokens and sentences and types in each one of these documents. Once the expansion of the corpus is complete, the preprocessing stage shown in the methodological proposal continues. For the preprocessing of the corpus, a standard pipeline was defined. As part of the methodology, the corpus is also used to build a domain-specific lexicon, as was mentioned before, where each term will be associated with a polarity and an emotion. One of the first steps in the construction of the domain's own lexicon is to define which term will be part of it. Classic NLP techniques such as TF-IDF for the extraction of the most important terms within the collection of documents are a way to obtain the initial list of words or seed words for the lexicon of the corpus. In the experiments performed to calculate the TF-IDF factor of the corpus documents, engrams were used to find collocations that are of importance within the analyzed documents. For each of the documents in the corpus, unigrams and bigrams were analyzed at the same time in the same experiment, then only bigrams, and finally trigrams. Larger engrams were not considered since no important placements of dimension greater than 3 were found. For the first 182 words for the greatest weight within all the documents, those that might have an emotional charge were extracted. This led to a list of 1,000 terms that were first classified by their polarity using centiwords, which is a lexical resource that contains English words associated with a sentiment score between -1 and 1. In a semi-automatic way, the polarity labeling of the seed words that were obtained through TF-IDF was carried out. The polarity labeling is considered semi-automatic because each term in Spanish was translated into English, searched for in the Centiwords list of terms, and if there were more than one entry for a word but with a different POS tag, the proper one was chosen. Subsequently, the same terms were labeled with the advice of 4 different experts in the analyzed text. This was done because some of the word's polarities may change due to difference in historical context. The set of emotions used to link the words of the lexicon to an emotion are those identified in the model of Plotchik's wheel. In this case, only the 8 basic emotions of the wheel are used. No intensity or combinations are considered for the labeling. After conducting the previously explained experiments and based on their results, it was observed that due to the nature of the text, the optimal way to evaluate the emotion identification model once it is finalized is through the evaluation of the data manually labeled by experts in this type of rating, because there is no existing validation set, also called gold standard. To carry out this validation, the text labeled with emotions by experts must be compared against the text labeled with emotions automatically thrown by the model once it is constructed. As a conclusion of these initial experiments with the dataset, we can say that the most viable methodology is to continue with the construction and expansion of a domain-specific lexicon with the advice of experts in the analyzed text. This is due to the fact that many religious terms have domain-dependent polarities different to general-purpose polarities. This is due to the fact that many religious terms have domain-dependent polarities. The size of the corpus is already sufficient for its future use in an automatic classification model where it is intended to use the lexicon as keywords for classification. The manual labeling will be used to evaluate the results of the model in which lexicon-based approaches and machine learning or deep learning will be combined. The next stage is to continue with the development of a methodology that can identify emotion in historical text consists mainly of combining lexicon-based approaches and machine learning or deep learning. A fundamental part will be defining the machine learning or deep learning model or tool that will be used for the classification. Once the machine learning or deep learning model is chosen, some of the possible approaches could be, on one hand, the use of the lexicon as keywords to classify sentences and measure their similarity. Later, make use of the classified sentences for training the machine learning or deep learning model. And finally, carry out evaluation of the predictions against labeling, manual labeling done by experts. Another approach could be to create class vectors, which represents the 8 different classes to be identified. Then, using the corpus, calculate the cosine distance between each class vector and sentence vector generated from the sentences on the corpus. So the vector with the greatest similarity or greater than a certain threshold will be assigned to that class. Finally, in this case, manual labeling is also used to evaluate the performance of this method. Finally, thank you for watching the oral presentation for this paper.